Hi, welcome to our new session of circuits and networks. In today's class, we are going to see the transient analysis of RLC circuits, and these problems we are going to treat as level 2 problems. So we'll start with the first problem where we can see a circuit is given which is in figure 1 shown with a switch which is open and inductor and the resistor parameters are connected to 5 volts. So initially switch was open for long duration of time. At t equal to 0, the switch is closed. We need to find out the node voltages VA of 0 plus and VB of 0 plus. So how do we solve this problem? First, we are going to see before switching conditions means what? We'll assume that the switch was open. When the switch was open, this 10 ohm is not connected. Hence, figure 1 is changed to figure 1A, and the currents which are flowing in the branch of 10 in series with 20 and 10 ohms, it is shown in figure 1A. Inductor, when it is charged, it behaves as short circuit for long duration switching conditions. So that is why this switch is closed over here. And when we are trying to estimate the value of I2, since we need to know the value of voltage over 20 ohms, so what we are going to do, we'll first calculate I2, which is nothing but the total voltage is 5, which is parallel to this 10 in series with 20, and also it is parallel to 10. So the value of current I2 would be total voltage divided by the sum of the resistors. So this current it is obtained to be 0.1667 amperes. Now the voltage across 20 volts can be obtained by taking this current and multiplying with the resistance value. So here the value of voltage is 3.33 volts. So exactly VA of 0 minus is obtained to be 3.33 volts. So this is our first requirement. Then this is node voltage VB of 0 minus. Here you can see this short wire is connected to the negative of this particular value of voltage, and anyhow this voltage value will be equivalent to 0 because it is shorted. Now current which is supposed to flow in the inductor that we are going to treat as IL of 0 minus, which is nothing but the total voltage but by the equivalent resistance. The equivalent resistance of this parallel circuit is obtained to be 10 parallel with 30. Now the value will be 5 divided by 10 into 30 by 10 plus 30, which is obtained to be here as 0.667 amperes. Now this is the conditions of currents and voltages before switching. Now what happens when the switch is closed? So when the switch is closed, the inductor behaves as the current source. So the current flowing was 0.67 amperes. And again we need to calculate the value of node voltages which is VA dash and VB dash. So here we are going to apply KCL at node VA dash, that is VA 0 plus dash. So that voltage value can be obtained using KCL by the formula as VA of 0 plus minus 5, because here the node voltage is 5. So VA minus this 5 divided by 10. Then VA by 10, this is another branch, and again we have VA minus VB, which is nothing but this node voltage, and that voltage divided by 20 is equal to 0. Likewise we are going to get the equation of VA and VB, and it is treated as in equation 4. Applying KCL at node VB plus of 0 plus, we are going to get the equation in terms of VA and VB of 0 plus, that is equal to minus 3.33. Now equation 4 and equation 5 you can easily solve, and you can get the value of VA of 0 plus, which is obtained to be 1.9 volts, round figure, and VB it is obtained to be minus 0.5 volts. So this KCL is a simple application. You can look into our previous problems how to apply KCL for a given circuit. Let us jump into the next problem. So in figure 2 we can see here again a switch was open, and the loop currents we need to calculate after the switching condition, and those currents are named as I1 of 0 plus, I2 of 0 plus, and I3 of 0 plus. So how do we solve this problem? So first assume that the switch was open. When the switch was open, the 6 volts is connected to inductor as well as capacitor, and inductor after charging condition it behaves as short circuit, whereas the capacitor it behaves as open circuit. So with this I'm going to get the open circuit voltage conditions of V1 and V2, which is across 0.5 and 1 farad, capacitor values, and the switch was open, that is why this is open, and the directions of I2 and I3 and I1, which are shown in clockwise directions, are taken as it is. Now you can see the inductor was shorted, right? So the total current of I1 dash, it is easily obtained as 6 divided by 2 plus 4, that is 6. So the value of I1 of 0 minus it would be 1 ampere, that you have to keep in your mind. Also you observe that the voltage V1 and V2, they are summed up over here because the capacitors are in series when the switch was open. Now the series net voltage value is nothing but the value of resistance, which is 4 ohms, and it has to be multiplied with current I1. Anyhow, this V1 and V2, we are going to get the value as 4 volts. How? Because we have already estimated the value of current, which is 1 ampere. Now 1 ampere, when it goes to 4, it becomes 4 volts. So the net voltage value is given by equation 1, and the current, it is given by equation 2. And the other currents, since these are open circuits, the values of currents are 0 and 0 amperes respectively. Now this information what we have obtained, that is V1 plus V2 is equal to 4, from the figure 2a. Actually the capacitors which are placed over here, which are in series, that is shown in practical diagram like this. Okay, now since the capacitors in series have the same charge, so I can write Q1 is equal to Q2, hence C1 V1 is equal to C2 V2. With that I can get the equation in terms of V1 V2 and C1 T2, which is given by equation 3. And from equation 1 we know what is the relation of V2 in terms of V1. So I'll substitute V2 instead of V2 as 4 minus V1, and I'll get the uh, value of V1 of 0 minus, which is equal to 8 by 3 volts, given by equation 4. And similarly V2 can also be obtained as 4 by 3 volts, given by equation 5. I hope you understood this transformation what we have done over here. Now actually when you close the switch, the charged capacitor, it behaves as a voltage source. So the capacitors are replaced by voltage values like this, and the inductor was charged to 1 ampere. So at t equal to 0 plus, this is the original circuit. Now this leaves the current to flow as I1 of 0 plus, I2 of 0 plus, and I3 of 0 plus. So how to calculate these values of loop currents? First we'll apply the KVL to the overall loop. You can see here we have minus 6 plus 2 of I1 of 0 plus, right? Then we have V1 of 0 plus and V2 of 0 plus, and that is equal to 0. So if at all you take the value of I1 of 0 plus, you're going to get the value as 1 ampere as estimated. Now it's a super mesh where you have 1 ampere shared by these two loops. So I1 of 0 plus minus I3 of 0 plus will be equal to 1, but I1 of 0 plus value is also is equal to 1. So I3 will be equal to 0 amperes. And you take the second loop where we have 4 shared by these two loops, I2 and I1, and then you have voltage 8 by 3, substitute equal to 0. So we have made it equal to 0 by applying KVL. Now substituting the value of I1, we are going to get the value of I2 of 0 plus as 1 by 3 ampere. So this is how we solve the transient based analysis problems. So the required value of loop currents are given by I1, I2, I3, which is shown by these boxes. I hope you like this particular session. Please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. In the next class, we are going to see the sinusoidal input applied to RL circuit and RC circuit, and we'll solve some numericals based on that. That's all for today's class. Thank you.